Good morning, students. It is 11th Physics, chapter number 4, lecture number 5. In previous lecture, we were discussing about the projectile motion. Now in this lecture, we will discuss it further. As I told you earlier, this projectile was thrown in this direction with velocity u. U cos theta will be component along x-axis and u sin theta will be component along y-axis. Now at any time, what will be angle between velocity and horizontal? We want to calculate that. Suppose I say at this point, this is horizontal. What will be magnitude of this angle? Suppose I say that angle is phi. So what is the magnitude of that angle? This is the horizontal component, there will be some vertical component, and it is its resultant. I can put this vector here. Now according to triangle law of vector addition, it is one vector, this is second vector, these are two sides, their order is same, then resultant will be given by third side. I am assuming that this distance is very small. If this distance will be very small, so in that case you can treat this curved line as a straight line. So this distance is very small. So at particular instant of time, what is angle? So this is the x component, this is the y component. Suppose I say it is ux and it is uy at that point, or vy at that point. Vx and vy. So in this triangle, what will be tangent phi? Tangent phi will be height upon base. Height upon base, height is vy upon base is vx. Now what is magnitude of vx and vy? Vx is constant along the horizontal, as I told you earlier. So vx is constant, which is u cos theta. Y component was continuously changing. Suppose this particle reaches at this point after time t. So what will be y component? V is equal to u plus at. So vy will be equal to uy minus gt, because z is acting against the motion. Our aim is to calculate vy. So vy is uy minus gt. So what will be tangent phi? It will be uy minus y suffix minus gt divided by vx. It is vy, sorry. Uy. So uy minus gt upon vx. That was the tangent phi. Now you can substitute these values. Uy is u sin theta minus gt upon vx is u cos theta. So at any time, what will be angle between horizontal and directional motion? That will be given by this. And one more thing, it was thrown from this point with velocity u. When it will strike at this point, its velocity will be same, that it will be u again, and this angle will be equal to this angle. Both the angles will be equal and velocities will also be same. Now suppose object is thrown parallel to the horizontal from some height. Suppose this is the surface and it is any height suppose any tower, and object is thrown parallel to horizontal in this direction with velocity u. So it was thrown in this direction. Its y component, initially y component was 0, but free fall will start, lower component will come into effect, and that will be path followed. This is the horizontal component, this is vertical component. Horizontal, vertical. Horizontal component will remain u because there is no opposing force along horizontal. Again we are neglecting air resistance. Along y-axis, this is x-axis and this is y-axis. Along y-axis, velocity is continuously increasing. So at any point, net velocity will be their vector sum. Now we want to find out in how much time it will strike the surface and what will be that horizontal range. For this we will take vertical component. Initial velocity was 0. Distance traveled, it is equal to h. Suppose this height is h. Acceleration due to gravity is g. Now it will take as positive because body is falling in downward direction and g is also acting in downward direction. So both directions are same. So it will be taken as a positive. So a will be positive. Our aim is to calculate distance. So we will apply the formula. S is equal to ut plus half et square. Now what is S? It is h. Initial velocity was 0, so this term will be 0 plus half gt square. Our aim is to calculate t. So what will be t? Twice h upon z, its under root. And this time, the body will strike the surface. Now, what will be horizontal distance traveled? This distance, which is r, horizontal range. That was x-axis. So, what is the horizontal range? Now, we will calculate horizontal range. We know time, we know horizontal component. So, distance traveled will be horizontal component multiplied by time. Because horizontal component is constant, so you can say uniform motion along x-axis. So distance traveled will be velocity multiplied by time. So in this case, horizontal range r will be equal to u into time, which is under root of twice h upon g. So that will be horizontal range in this case. So that was all about the horizontal component and projectile motion. Now I will take basics of circular motion. Our next topic is circular motion. We will discuss it in detail. In this lecture, I am taking only the basics. Suppose it is circle. It is its radius, origin O, center O. On this circumference, take an arc whose length is equal to radius. Suppose I say this arc is equal to this radius. Join it with the center. So this angle will be formed. That angle will be equal to 1 radian. Suppose it is point A, it is B. Arc AB is equal to radius. So this angle formed will be 1 radian. So how will you define 1 radian? It is angle formed by an arc with the center when length of the arc is equal to radius of the circle. I am repeating. It is angle formed by an arc with the center when length of the arc is equal to radius of the circle. So that will be 1 radian. So this angle will be 1 radian. In circular motion, angle is taken in radians. So that angle will be 1 radian. Now, question is, what is the relation between degree? We have studied the angle in degrees, 60 degree, 30 degree. In one rotation, total angle is 360 degree. So what is the relation between radians and degree? If this is the total circumference, 2 pi r. 2 pi r is the total circumference. It will be equal to 360 degree. Before that I will calculate. If arc is equal to r, then angle will be 1 radian. If it will be 1, then it will be 1 by r radians, and total circumference is 2 pi r. That will be 1 by r into 2 pi r. 2 pi radians. So in one complete rotation, there will be 2 pi radians. And we know that what is the relation between radian and degree. 2 pi radians, one complete rotation, it will be equal to 360 degree. So pi radians will be equal to 180 degree. Or you can say 1 radian will be equal to 180 pi degree. So this is the relation between radian and degree. Suppose this is the starting point. It will take some time in completing one rotation, that is called a time period. So time period is time taken in completing one rotation. Suppose any object is traveling this path, along this path, along this circular path. So how much time will be taken in completing the one rotation? That will be time period. So time period, and next is frequency. Frequency is the number of rotations in a unit time. In t time, number of rotations equal to 1. So in unit time, it will be 1 upon t. That will be frequency. So frequency will be equal to 1 upon t. So if you know the time period or frequency, then you can calculate the another. If you know frequency, you can calculate time period, and if you know the time period, then you can calculate frequency. Frequency is reciprocal of the time period. Till now we have studied about the linear velocity, displacement per unit time. Now we will discuss about the angular velocity. Angular velocity is angle travelled in radians per unit time. In radians upon time. So it will be radian per second. So radian per second will be its unit. So that will be angular velocity, and this angular velocity is denoted by omega. It is Greek letter omega. Omega. So angular velocity will be denoted by omega, and it is radian per second. In next lecture, we will discuss about the velocity, acceleration. A particle is moving in circular path with a constant speed. I am repeating, A particle is moving in circular path with constant speed, but there will be acceleration. Why there should be acceleration? Think over it. In next lecture, we will discuss about this. Okay, thank you.